Okay, this is my video for the article that I read. The article title was Real Electrodynamics in a Plasma Armature Railgun. And I'm going to start off with the introduction, which deals with it tells you what a railgun is and what the difference between two different types of railguns are and what's going to be studied and what has been studied in the subject. Start off with what a railgun is. The Lorentz force is what propels the projectile forward, and it's called a gun because it shoots out some sort of a projectile. And it does this by using a power source that puts a current through a rail, which is usually copper rail, and then it goes through this thing called the armature, which is there for a bridge, to bridge the gap between the two rails. And then the current goes down through this rail and back out. And now the reason that this works is the Lorentz force is the integral of J cross B dV, which I will explain how that works here. This current right here will create a magnetic field that, if you use the right hand rule, goes this way and curls up, so in the middle it's coming out of the board. And then for the other side, it goes this way, so it's coming out through the board in the middle again. So the magnetic field in the center is straight out of the board. And then you have the current density in the armature, which is straight up. So if you use the other right hand rule, you can see that the magnetic field is your middle finger, your index finger is the current, and your thumb is the force. So you do this, and you can see that the force is pushing the projectile out at high speeds. The type of railgun used in this article was a plasma armature railgun, because it can shoot the projectile at approximately 6 kilometers per second, where a solid metallic armature can only propel projectiles at a velocity of 1 to 2 kilometers per second. The studies that have been done are to reduce deformation of the system, problems with the projectiles, trying to improve the contact between the armature and the rails. They try to avoid plasma blow-by, and among others, they don't want the plasma to leak any either. So then we'll just move on to describe the system to help with the coordinate system. All these outside things are rigid, with a rigid containment structure, and I'll talk more later about the assumptions that are made in this paper. And one of them is that the containment structure does not move or deform at all. Then these backing materials, which is right here and right here, are what's is gonna be the elastic thing in this study that allows the rails, which are right here and here, to move. And then the insulators are there to fill the space so that there's nothing to conduct a current across there. And the coordinate system is going to be X is coming out of the board, Y is up and down, and then Z is left and right in this diagram.